We're here with the 3D lab here, the IDTechEx Show. And who are you?
I'm from the 3D lab. We're an institute in the technology of Berlin.
And what are we looking at here?
We're looking at the famous polar bear Knute, actually, which died in 2011. And we had a project to reprint the skull. And this one is actually a fun project, printing the head because we can.
How do you do that? Do you use 3D printers?
We did use 3D printers, in this case gypsum-based 3D printer, and we separated it into smaller parts because of the limited build volume, and then glued it together.
Cool. And so you 3D print this?
We also 3D print art. We have a cooperation project with museums in Berlin for restoration purposes, and this is one piece of them.
But this, how can it be so detailed, and how can all these shapes be done by a 3D printer? It's not an issue?
It is an issue. We figured it out. We do a 3D scan, and then do the pre-processing on a computer, make it processable for the machines, buildable, and then we print it, and then there's extensive post-processing to make it look like real plaster, like real art.
Post-processing?
Post-processing.
Like scratching it a little bit or something?
Oh no, it's infusion with epoxy resin and some other secret ingredients.
Secret stuff. What is
this?
It
looks like this. This is a mathematical object, actually, and there's one edge that's missing. But the interesting thing of this object is you always take the middle and take out the volume. Then you divide it into smaller cubes and take out in the middle the volume, and so forth and so on and so forth and so on. So in the end you have an infinite large surface with an infinite small volume. Computers may go to the third, fourth or fifth iteration, but then usually it's over with the memory or processing speed, and it takes ages. But I think this is the fourth iteration, and let me just count.
So you have many different parts, you put them, glue them together?
No, this is printed in one piece.
In one piece?
In one piece, and we have two other models which are missing right now.
That's a pretty good 3D printer you have, right?
Yeah. We do have some very good 3D
The best one in the world?
I assume one of them is close to the best one in the world.
All right, and here you have a golden planet.
Yeah, this is actually it's the moon. It's the Earth moon, and we printed this several years ago, and then plated it with 24 carats of gold.
That's awesome.
And yeah, this actually does not come from a colored height map. This is real data from NASA.
It'd be awesome if the moon was gold.
Our moon. I don't know.
No, it'd be strange. Okay.
Might be. I don't know.
And there's some other mathematical stuff?
This is a mathematical object, right? But I'm not a mathematician, so I don't know.
Yeah. Let's go around. What's going on here?
This is actually educational models which show defects of, first of all, how the heart works, how the heart valves work.
Is that 3D printed?
This is 3D printed as well, right? And this is actually a current research project, heart valve replacement by tissue engineering and 3D printing.
And it looks, you painted it?
No, this is printed this way.
Printed with those colors?
This specific machine does colors, right?
Oh, and this?
Actually, this is the distribution of cells in a three-dimensional grid.
Oh. Where do you put those things? Only in your office, or do people have them somewhere? It's for universities, or?
No, this is for university purposes, educational purposes, or just for getting an overview what we are talking about. So in discussions, this helps a lot.
Where? In Germany?
In Germany. Yeah. This one, for example, is a part of a dog's bone, and this is for pre-surgery research, so the surgeon gets a good overview over what he has to do inside of the animal. In this case, we get the computer tomography scan, we work with the data, make it processable, and then we print it and then give it to the surgeon for surgery planning, actually.
All right, and here we have
And this was the original work we had to do with a polar bear.
yeah.
And this is the skull of Knute, and this was specifically interesting to show the audience, which wanted to know why the bear actually died, what he died of, and what he not did die of. And in this case, someone assumed it might be a genetic defect, but genetic defects that lead to death usually also result in deformations and asymmetry in the skull. But with this ethical, unproblematic model, you can show and you can see that there is no deformation, there's no asymmetry in the skull. Therefore, the theory of a genetic defect is wrong. And this model gave the researchers several years to explore the reason why the polar bear died for real.
Right, and this looks very nice. Where's the original? Is it in Rome?
No, it's here in Berlin. It's a figurine in the tea saloon, which is quite bigger. The original is 1.20 to 1.40 centimeters in height, and we scanned all of them, all 15, and then reproduced them in a smaller scale for exhibition purposes.
That looks really, really nice. Where do you exhibit?
We don't. The museum does.
In Berlin.
In Berlin.
All right. So what's going to happen in the future?
Well, what's going to happen in the future?
We get some crazy 3D printing projects.
We still have we have a biomedical project, and we are about to acquire some new projects. But this takes time. We are a university, and we'll see what science brings.
So you have lots of students in the 3D printing class?
We do have 7 students working with us and for us. This is, just quite a few. We have several interns also working for us. We have postgraduates, and we do have scientific assistants as well.